Hi everyone. In this video, let us discuss design patterns. Design patterns are well-proven solutions for solving specific problems while we are working in a project like in object-oriented design or software design. There are three types of design patterns. Those are creational design patterns, structural design patterns, behavioral design patterns. What is mean by creational design patterns? Those are actually it deals about how our object is created and how many objects are to be created. They are uh, the examples for creational design patterns are factory, abstract factory, singleton, prototype, and builder. And the second one is structural design pattern. The structural design pattern, it is about how class will be structured, what attributes will be there in a class, how will be a class interact with classes. And the example for these are adapter, decorator, facade, flyweight design patterns. And the third one is behavioral design pattern. How you solve behaves, like how the code will behaves in action. It's about that. So now let us discuss about singleton design pattern. So what is the singleton design pattern is saying? So basically, if we want a class to have only one object, then we use the singleton pattern. And when is the need? The need for it, suppose they are the objects used for logging device drivers for printers or registry. So they have only one kind of object, like they should not have multiple objects. In simple words, we should say whenever the class should contain only one object, then like there may be thing of creation of the object is very expensive, or only one object is enough, like this thing, like this is the problem statement. Then in that case we should use singleton design pattern. For this, let's take logger example, and let's create the l- public class logger. Now in the test logger, let's just create the object of that logger. Object 1 is equal to new logger, and similarly logger object 2 is equal to new logger. So so we created the two objects for the class logger, but we want only one object, right? So you can print the their address like hash codes object2 dot hash code. So when you run this, you can see there are two memory address we can see here, but we want only one object. Whenever we are going to create second object, it should not be created. So let's understand that. So here, whenever we are creating new object, there is a public logger constructor, right? That will initialize the object. So basically by default it will be public. Suppose if we make it as a private, then we can't create the object here. You can see here in the test logger, it is red mark. The error is there, like change visibility of logger to public. So what I'm going to do here, the second step is I'm just making an logger object here itself, logger. Then I'll just create a here one public uh, return type is logger, and the one is get instance. So here I'm just writing the code. If my logger is equal to null, then that time I will create one new object, new logger. Suppose if it is not null, we'll just return the same logger object here. So here I'm making this one as a static. Then I'm also making the logger object also static. So whenever we make the static function here in the main method, instead of creating the new object, we can call by using that class name logger.getInstance, and here also logger.getInstance. So if you run this code, now the address is same. So whenever we are creating the new object, it will go there. So it is already created, it is not null, so it will return the same object. So this is how we can achieve singleton design pattern. Now let us discuss singleton design pattern in multi-threading environment. Here we created two threads, thread T1 and thread T2, and inside it we are running this or creating this object one. Also I'm printing that address. So it should show the same address, right? But it is not showing. Like object one is showing different address, object two is showing the different address, two different objects is created. So why it is happens in a multi-threading environment? Because when you that function, when the object is calling this function, both threads calling it at a time. So when you're simultaneously calling it, two different objects is being created. So to resolve it, we should use here. So after using synchronized keyword, it will do just it will just stop another thread T2. It will just allow only one thread to access. After its completion, it will allow the second thread. So if you run now this code, now we can see only one object is created. It prevents creation of the second object. So this is about singleton design pattern in multi-threading environment.